What's up, geometry? So this video is about special angles on parallel lines. Now, to be very successful at this part of the video, or the problems, or I don't know, whatever you want to call it, to be very successful at this, we need to be very familiar with these two terms: the linear pair and the vertical angles. Alright, so I left a picture of the linear pair right here. This is a linear pair. I don't know, your teacher might have called this a sunset or a sunrise or whatever to help you remember. Okay. Technically speaking, we have two angles that are adjacent or next to each other that are also on the same line. They share the same vertex. Alright, so remember that a linear pair always adds up to 180 degrees. Okay, the other angle relationship that we need to be very familiar with is the vertical angle. Now, the vertical angle, your teacher might have called this a bow tie or whatever it is, but technically speaking, the vertical angle talks about two angles that are across from each other. Alright, they're across from each other, they share the same vertex, okay, and the special thing about them is that they are congruent. They are congruent. Okay, so we got linear pairs. For the linear pairs, there are two angles that add up to 180, and for the vertical angles, there are two angles that are across from each other. They are congruent. Now, knowing these two pieces of information, we should be able to figure out what all of these angles equal to. Alright, geometry, so here I have an example. These are parallel lines, let's say they're parallel lines. Alright, so I give you an angle 70 degrees. Okay, I give you an angle 70 degrees. You should be able, just focusing on that top part, you should be able to tell me what all three of these angles equal to, using your knowledge of linear pairs and vertical angles. Alright, you should notice that these angles over here form a linear pair. They form a linear pair. In other words, these two angles should add up to 180. So if one of the angles is 70, then the other angle has to be 110. Now I'm going to use my knowledge of vertical angles. Alright, check out these two angles right here. These two angles are across from each other, and they share the same vertex, so this should be 70 degrees. Same thing on the other side with the 110 degrees. Alright, these two angles are across from each other, they share the same vertex, so this angle is also 110 degrees. Okay, so we filled out the top part. Now, assuming that these lines are parallel, what do you think? Just think about it for a minute. What do you think these angles would equal to? Right? What do you think these angles would equal to? I'm going to give you a couple of seconds to think here. Alright? If you were thinking that the angle measurements of this top portion, or this top half, should match with the angle measurements in the bottom half, alright, that is exactly correct. Alright, in fact, you could take a piece of tracing paper, right? You could take a piece of tracing paper, you could trace the top half and just line it up with the bottom half, and you would see that the angles will be exactly the same. Alright? So now notice, assuming that these lines are parallel, notice how many congruent angles we have, right? And this is where all of the angle relationships come from. Alright, so I sort of redrew the diagram here for you, just so that I can explain what these angle relationships are all about. So in the previous frame, we just explained how in this particular diagram, in this particular setup, assuming that these lines are parallel, we have so many congruent angles here, right? We have these 70-degree angles, these 70-degree angles, these 110-degree angles, these 110-degree angles. I'm going to go ahead and label them now, just to make this part very clear for you. I'll use some letters here. I'll go with A, B, C, D, E, P, I don't know, E, P, S, and M. Alright, so there are my letters. Now, alternate interior. Well, let me first talk about one last thing, alright, before I go into the angle relationships. When you see the words alternate and corresponding and all that stuff, all of those words have to do with this line right here. Remember, this line is called the transversal. Okay, transversal. This line is called the transversal. So now, if I'm talking about alternate interior angles, alternate means opposite. Okay, alternate means opposite, or different sides, or whatever, right? Opposite or different sides. So what alternate interior angles are looking for are angles that are on opposite sides of the transversal inside of the parallel lines, that are congruent. Okay? Remember that alternate interior angles are always congruent. So again, I'm looking for angles that are opposite of the transversal inside of the parallel lines and also congruent. Well, I only have two pairs. I have A and S, right? I have angle A and angle S, and I have angle P and angle C. Right? Those are my alternate interior angles. For the alternate exterior angles, I'm looking for angles that are on opposite sides of the transversal. In other words, one on the left, one on the right. And on the outside, right, outside of the parallel lines, so either angle DB, angle D and angle B, or angle E and angle M, right? They have to be on the outside. And they are also congruent. Right? Alternate exterior angles are also congruent. So looking at these outside angles, D, B, E, and M, well, there's only two pairs, right? Angle E on the left side and angle F, oh, that's a B right there. Sorry. So I got angle E on the left side and angle B on the top right. So there will be alternate exterior angles. And I have one more pair. I have angle D at the top left, and I have angle M at the bottom right. Corresponding angles. Well, corresponding is pretty much the opposite of alternate. Alternate means on opposite sides. Corresponding means matching sides. Alright? So when I look at this diagram, I want to look for angles that are on the same side of the transversal, so they're either both on the left or both, sorry, the hand motions aren't matching my what I'm saying. They're either both on the left or they're both on the right, and they are also congruent. So corresponding angles are also congruent. So I don't know, let's start by looking at the left side of the transversal, right? Here's my transversal, I'm going to look at the left side. So if I look at the left side, which corresponding angles do I have, right? Which angles on the left side are congruent? I have angle D and angle P. And I have angle A and angle E. I can also bring this to the right side. Looking at all the angles on the right side of the transversal, which angles are congruent? Well, I have angle B and angle S. And I have angle C and angle M. So these are what we call our corresponding angles.